Okay, welcome. Today we're going to talk about proportional relationships on graphs and specifically focusing on a constant of proportionality and what that is and what it means. When we talk about proportional relationships in graphs, the first thing we want to do is actually define what our variables are. So when we're looking at graphs on the coordinate plane, we're specifically looking at our x and our y, and one of those is our what's called our independent variable, and our other one is what we call our dependent variable. Our independent variable is going to be our x. This is our input value, or the value that changes, or the value that is changed. And we are going to always graph this on our x-axis. And then our dependent variable is our output. So if you think of like in and out tables, and this is going to change depending, right, based on the input. And we're going to graph this on the y-axis. So we can think about the fact that y is always going to depend on the value we input for x. All right, so to check if something is a proportional relationship, the first thing that we have to see is that the graph is a straight line. If there's any sort of curve or anything like that, or points are not in a line, then it is not a proportional relationship. The second thing is that the graph must pass through the origin. And if you forget what that is, the origin is our point 0, 0. And we also have to have a ratio of y to x that is constant. And we call this value k. And this k value is what is called our constant of proportionality. So for an example, if we have a line that passes through 0, 0 and 3, 6, then we can look at the change in our our y and our change in our x. So we have that our y value is 6, so that's why it comes first. Our x value is 3, that's why it comes second. 6 divided by 3 is 2. So our equation is y equals 2x, where 2 is our constant of proportionality. Oops. All right. So we are going to practice this. So we're going to look at this line that we have over here on the left. So as we're looking at this line, we're going to first ask ourselves, does it pass through 0, 0? So if we look here, yes, we can see that it passes through 0, 0. So this is a true statement. If it didn't pass through 0, 0, then it wouldn't be proportional. Next, we're going to find a clear point on the line x, or on this line, and find its ordered pair. So for example, I could use this point right here. I could use this point right here. I could use this point. So anything where it is crossing kind of at those intersection of those grid lines. So I'm going to go ahead and pick this point, and I'm going to use 2, 4. And now we're going to use that point to help us determine our constant of proportionality. And once again, we know that it's a constant of proportionality because it is going through the point 0, 0, and we have a straight line here. We don't see a line that's curved or gaps or something else going on. So we're going to take our y value that we chose, which is 4, and we're going to divide it by our x value, which is 2, giving us a constant of proportionality of 2. So in this case, if x is hours and y is our number of dollars earned, what does the constant k tell us? Basically, it's telling us that we are getting $2 per hour. And that's our constant of proportionality in context. All right, so let's take a look at another example here, but now we're going to find our constant proportionality from a table. So once again, just like when we were finding out if a relationship was proportional, it's kind of the same idea. So we're going to look at seeing if we have that constant rate between all of our data points, right? So 112, 224, 336, and so forth. And then we can use that formula that k is equal to y divided by x to figure out our constant proportionality, which is really just looking at, right, that same value as when we were finding the rates. So in this particular problem, you can see that I've already figured out all of our rates for each one of our 4 data points, and it was all 12. So in this case, because 12 divided by 1, 24 divided by 2, and so forth, they're all 12, our k is equal to 12. So we can go ahead and put that in. And so since it's always the same, the equation is going to be y equals 12x. So when we're doing a proportional relationship, our form is always going to be y equals kx. So the x and y will stay the same, and then k is always going to be that constant of proportionality. All right, so now I want you to pause the video, and I want you to see if you can figure out and find the k from our number line and our graph on the right here. All right, so first of all, we can see it's a proportional relationship because once again, it goes through 0, 0, and we have this straight line. So you're going to pick a clear point where it crosses the grid. Once again, you could use this point, you could use this point, we could use this point, we could also use this point. The only point we really wouldn't want to use is 0, 0 because we can't use those values. So no matter, and here's the thing, no matter which point you would pick, you would end up with the same constant of proportionality. I'm telling you to use the point where x equals 4. So I'm going to go ahead and find where x equals 4 and find my y value, which is 2. So in this case, we're looking at 4, 2. So I'm going to take our y value, which is 2, and divide it by 4, which we could write as either 0.5 or 1/2. So the value for k is equal to 0.5 or 1/2, and our equation would be y equals 1/2 x or y equals 0.5 x. So one last thing just looking at is how the k affects our graph. So if you think about, if we go up, back up here, if we went back to the previous page and we looked at that y equals 2x, and then here we have where our k value is only 1/2, hopefully you notice that, for example, here if it was k equals 3, it would mean that we're making, like, for example, $3 per hour, whereas if it was 0.5 here, we're making like 50 cents per hour if you're using the same context. And so that k equals 3 would make a much steeper line. So you're going to see it rise or look a lot sharper when we're looking at that change. So if we went up here and graphed that k equals 3, it would still go through 0, 0, but now it would be something when x is 2, we'd multiply it by 3, so we'd be here, and when x was 4, we'd multiply it by 3, and it would be 12, which would be like way up there, right? So we see this much sharper line, if you want to think about it that way, when we're looking at that. And so the bigger the k value, the steeper our line is going to be. And so that's looking at constant proportionality. Just to summarize, k is our constant proportionality. It's going to be that constant value you see between your y and your x. It's always going to go into that form y equals kx. The x and y will always stay, and then it has, in order for it to be proportional on a graph, we have to see it go through that point 0, 0. Please reach out if you have any questions.